So today on Scares and Sparks, I'm going to show you how I created a bell tower for the Bell Haunted Manor. The bell tower is going to keep real time, it's going to chime every 15 minutes, and every hour it's going to count you down. It's also going to be moving a servo motor to move the bell physically to match the dings of the bell. So 3 o'clock, you're going to see the bell move 3 times and ding 3 times. Quite uniquely, I'm going to be creating almost all of the software code for the Arduino using ChatGPT, which enables you to create small applications like this really quickly and easily.
Okay, so here's the basic bell tower that I've built to house the bell. Just made from scraps of wood, and these are fence panels on the side. Cheapest way of getting planks. They're all quite warped and bent though, so I have to kind of untwist them at the bottom. All the brackets just hold it together. The bell dismounts by this chain, has a string on the back. We'll put the electronics and a servo up here. Simply be able to yank on the servo and make the bell swing. Okay, so electronics are mounted. Servo's just sitting here with in one of my brackets. Electronics box there. I've got a light that kicks off when the thing fires. Put it up there for now. I don't know what that will look like. But temporarily I put a speaker on the top just so you can hear it. And I'm just going to plug a battery in just to show it in action. Four dongs, must be 4 o'clock in the afternoon. Whenever you fire the thing up for the first time, it always plays the number of hours, just so you know it's working. So the electronics for the bell are based around my standard prop controller board. That's got an Arduino on there. It's got a DF mini player, which has got the sound on this memory card, which makes the ding sound from the bell. It's got a servo it's controlling on one of my servo mounts. It's got 2 outputs at the moment. For testing, there's a small speaker, but then also I want to get this plugged into my mixer for my graveyard audio, so I've got a 3.5mm jack plug on an extension as well. That comes out the DAC outputs from the little DF Mini. Got a usual 5-volt power supply board and a MOSFET for outputting to a light, so when it triggers you can plug a light in here and it will shine at the bell. The only thing that's a bit weird looking, in here we have a DS3231 real-time clock with a backup battery, and that's simply wired into I2C and power. The reason it's wrapped in tape is just basically because I just want to make sure it didn't short circuit anything when it's all got the lid on the box. So what happens is that guy's running all the time. When it hits 15, 30 or 45 minutes past every hour, it will give me 1 chime, and when it hits the hour it will actually give a number of chimes equivalent to the hour. So 7 o'clock will give us 7 chimes. All you need to do with this for getting the time into it is program it just once. When you very first program the unit, serial port comes up and it asks you for the time. Once that you've done that, it's set forever.
So creating little sketches for your Arduino can be a bit of a drag sometimes. A lot of them are just exactly the same stuff for most of it, apart from a few little bits per different project. So what I want to do is show you how using ChatGPT you can actually get it to write the code for you. So for my bell tower, I started off and I thought, I know what I'll do. I'll just give it a basic sort of instruction set, see what it comes up with, and then add to it as I went. So this is what I typed in: create Arduino code for an alarm clock, use a DS3231 real-time clock, set the time in the console on the first programming, and on every hour set the GPIO. Now you put that in and ChatGPT is going to basically explain what it thinks you want it to do. It's going to tell you what libraries it's going to use, and then it's going to start developing and generating the code for you. And then it even explains the various different functions that it's used and tells you how to test it and what it should look like in the console. So quite amazing really. because otherwise, if you'd had to write it from scratch, you'd probably be here another 20 minutes doing that. And just having a quick scan through the code all looks pretty sensible. Now, you don't need to be able to understand this code, of course, to use it. You could just literally download this into your device and see if it works. But what I did with this one then is I started to then try and refine it. So at the moment, this is just storing a clock and raising a GPIO pin, which is not terribly useful. So the next phase was basically to add in a audio board. So I use the DF Player Minis quite a lot, so I figured let's try using one of those. So here's my instruction to it now. Add a player, make the audio player bell sound every hour that passes, make the bell chime and GPIO pin toggle the same number of times as the hour. So the idea being if it's 3 o'clock, you're going to get 3 chimes. So all we do is we just push the button. Again, it tells you exactly what it thinks you want. It tells you what its pinout is going to be using, and it tells you which libraries to install. It even tells you how to install the libraries, and then it gives you updated code. And you can see here, just scanning through, it's using an I2C library for the real-time clock, a real-time clock library, and now it's added the mini player. It goes through, you can see here that it basically then sets up the mini player as normal, sets its volume, and then carries on setting up the real-time clock, and then in the loop it's basically sampling the hours, and when it changes, if current hour is not equal to last hour, so that's precisely just as the clock has turned over, then it prints out playing the bell sound. It plays the first track on the micro SD card, waits for a little bit, and then toggles the GPIO pin. Now that's not quite what I wanted, because I actually wanted it to chime the same number of times as the hour. So it's done it for the GPIO look. It goes between 0 and then the time is less than current hour. Then it will do the alarm pin. So actually all we need to do is we would move this line of code here down into this for loop, and you will find that it will actually give you your chime every time the hour hits. So it's not quite understood exactly what I wanted, but it's got very close to it. So the other thing I wanted to do was basically move the bell. So I'm just going to use a servo motor for that. So again, next stage, I'm just going to tell it to fix the bell chiming so it rings multiple times, and then add a servo into the loop. And again, you'll see it tells you how to wire the servo up, which pin it's picked. You might want to use a different pin, but it's given you the starting point. And then if you look through the code, you'll see that there's not a great deal of difference to it. If I just wait for it to finish, here we go, the main loop here. So let's go up to the top. So now it's included the servo library. Now it's instantiated a servo and put it on a pin. And then if we go down to the actual code itself, well, here's the attachment and telling the servo where to go to start with. And then in the code, you can see now in the for loop, it's toggling the pin. It's now playing the bell sound each time, and now it's moving the servo position as well. So what will happen is each time the thing chimes, it moves the servo and just does that repeatedly, backwards and forwards to move the bell. So with just 3 sets of instructions, we've now got a complete piece of code for the design. Now, the next thing to do would be things such as changing your pin out. Say your servo is not on pin 9, say it's on pin 7. You can just tell it, my servo's on pin 7, and it'll go, okay, I'll just regenerate all the software for you. The same with the volume. If you think that's going to be too loud, too quiet, you tell it what volume you want. So very quickly you can build a complete framework with this thing, and then you can tweak it afterwards as you need to do. And that took literally seconds to do to get a working example. Okay, so you might be wondering what the final code looked like, what other changes I made to it. Could have done it all with ChatGPT, but by then I'd done 90% of it, so then I fiddled about on my own with this. So the first thing I do on my Arduino code, I've got the actual map of the chip. I always put this down along with which pins and things to connect things to. It's got the same sets of libraries pulled in as before. The only new one here that's sneaked in is the EEPROM. I'll talk about that in a minute. Basically, my light's on pin 6, my DF player's on 13 and 12, my servo's on pin 9. The rest was the same. In the setup, I'm making sure I turn the light on, I attach the servo, I initialize the DF mini player, set the volume, and then the EEPROM is an interesting one. So the design before, whenever you turn the thing on the serial console, you'd have to put in the time and the date, which was great, but every single time I rebooted it, I didn't want to have to keep putting that in. So what I do is use literally the first location in the internal EEPROM to store a flag to decide whether it's already been programmed or not. So I'm reading a value from the initial, from the first location in the EEPROM, and I'm saying if the value is 255, which is the value which will be returned if the EEPROM is blank, then you run off to this set time via console. And set time via console is the same one that ChatGPT had basically. It allows me to put in the year, month, date, hour, minute and second. And then the interesting one, the one I added, was to log to the EEPROM that we've stored the time. So what I do is I set the value of 55 to this location, print out that I'm set. So now what will happen if we run the program again when we power up? It will come here, it will read that location, it will see the value is 55, and it won't bother asking us to reset the thing. So, and then we just say we've loaded the time from EEPROM. Easy as that. So I did a couple of different things here. I did a little bit of error checking on the times, and this was largely before I'd worked out how to do the EEPROM properly. And what I do is I've actually got I'm keeping track of the minutes and the hours. And the reason I'm keeping track of the minutes is that what I made it do is every 15 minutes, so 15, 30 or 45 minutes, it plays a single chime, one single dong. And I've got a little function here called do the dong. And do the dong is down here, and that will turn on the light, move the servo, wait for it to settle, move the servo back, and turn off the light. Simple as that. Now, I just lost track of where I'm going. So that's this one here, and I'm also playing the actual sound file just once in that process. Now, on the hourly change, we keep track of the hour. When the hour change turns over, then again, a little bit of formatting and just checking on things just to make sure that the real-time clock gives us a proper value. And then if it does, then I basically send the sound file and also do the dong for the number of times that are in the hour. So if it's 8 o'clock, you're going to get eight sound files played and 8 dongs. And that is basically it. It just repeats. So the real-time clock stores the time. You put it in once on the console. It stores it in EEPROM that you've made that change. If you ever want to reset the thing, all you have to do is reprogram the Arduino and tell it to overwrite the EEPROM as well, and then it will be reset to the factory. So we went from a ChatGPT, which got us probably 90% there, made a few little tweaks to it to get it how we want, and now we have a completed piece of code.